Hello, in this video we'll learn how to scale applications in Kubernetes using either manual scalability or automatic scalability by using HPA, which is horizontal pod autoscaler. HPA can watch for your CPU and memory utilization of your pods on your cluster, and then it can make the decision either to increase or decrease the number of replica of your pods running inside the deployment with respect to minimum and maximum number of those replica. So let's see how that works in action. So to start our demo, I'll start here by creating a new Kubernetes cluster. For that, I'll be using Azure Kubernetes Service, but the demo here for today is actually applicable also to other managed Kubernetes services on the cloud and also applicable for Minikube, which you can use to run Kubernetes cluster on your local machine. So from the Azure portal, I'll go to create a new resource, which is gonna be here Kubernetes service. I'll give it a name. I'll call it, let's say here, AKS demo. And I'll use the same name for my resource group and also for the Kubernetes cluster. Then for the region, I'll use here West Europe, for example. Choose whatever region near to your customers or near to your other resources. And then for the Kubernetes version, I'll go to choose the latest in GA or general availability. And here I create the cluster with 3 nodes. That's okay for me. I can also go to change the size of it for those nodes. And then for the other steps, I'll just leave it at default for the authentication, where we can enable airbag, for example, networking, integrations, and so on. And then I'll go to review and create, and here Azure will validate the entries that I have pushed. And then from here, I can go to create the cluster. Let's hit create. This operation will take from 2 to 5 minutes. So let's wait for that and let's go back later. Once the deployment is complete, now I can go to resource, and from here I get access to my Kubernetes cluster, where I can see the version and the different metadata about my cluster. I'll go now to connect to my cluster. So here I'm connected to my Azure portal, to my Azure subscription by using AZ login command. So I have already done that. And then I'll go to list, I go to AZ AKS list my Kubernetes clusters in a table. So that's my AKS demo cluster. Now I'll go to connect to that cluster using the AZ AKS get credentials command. So from here I pass the resource group, which is AKS demo, and then the name of my cluster, which is the same here as the resource group name, and I'll click enter. And now this command will connect to my Azure subscription to that AKS cluster, and it will retrieve the credentials in order to connect to that cluster, and it will merge that into the kubeconfig file. So here I accept to merge it. And from here I can connect to my cluster. So I make sure that I'm connected by running the command kubecontrol get nodes. And here I see my 3 nodes deployed into that cluster. I can also run the command kubecontrol get pods, and from here we see that there is no pod deployed into the default namespace. So let's start by deploying a sample application into this cluster. We'll go to deploy a sample application here that is available on my GitHub repository, where here we have the source code for those YAML manifest files, and I have copied those, or I have cloned those into my local machine, and here I have opened it with VS Code. So I start with deploying a sample pod into my Kubernetes cluster. So here I have a deployment, and then from here I go to deploy this image, call it HPA example, and I have set up the resources for this image to say what is the minimum required in terms of CPU for this image, and what is the maximum that shouldn't go be above of that. And I have also added a service to that pod so that I can reach that pod later when I go to ping that pod using curl. So I'll go to deploy this file. So for that I'll use kubecontrol apply dash f, then the name of that file, I've called it deploy dash svc dash dot yaml. So I'll go to deploy it into my Kubernetes cluster, and that will create the single pod. Let's check now that that pod was created. Kube control get pods, and here we should get that single pod created, and it's still creating, by the way. So now let's imagine that we want to scale out this application. We are getting lots of load for this application, and one single instance is not enough. So we want 2 instances, for example. So there is multiple ways to do this. First is that we can go to change this number of replica inside the YAML file, and that's the easiest option actually. So I can go change this to 2, and that will deploy it again, and that will update the state configuration in Kubernetes to run 2 instances of this. I can also use the command line. And with the command line, what I can do is that I can use the command kube control scale the number of the targeted replica, which is 2 in this case, and then the name of my deployment that I have called it PHP Apache. So when I run this right now, this will talk to the Kubernetes API, and it will tell it to add another instance of my application pod. Now when I get the new list of pods, this will give me 2 pods, with a new one is being created a few seconds ago. So this is manual scalability. This is just fine if you are testing and if you know when you will get lots of load for your application. But in real world, you know, this is not useful at all, almost, because in real world you don't know when your customers will be using extensively your services and when they will generate lots of load for your pods. So we better be prepared using automation. For that, here we want to automate this scalability for our application. So what we'll do here is that we'll be using the HPA, horizontal pod autoscaler. Instead of having us manually setting those number of replica, we'll give this control to the HPA. So let me walk you through a complete example on how this works. So I have added here another YAML file that is the load generator deployment. And this one will generate that we have a container or a pod that will try to connect in a loop to the service that we have deployed earlier, which is the PHP Apache. Remember, that was the name of the service here, call it PHP Apache, that we have deployed earlier. So we'll deploy 2 of those containers in order to generate lots of load, and we'll see what will happen to our containers. So I'll go to deploy this file. So again, I'll be using kube control apply -f, then the name of that file, which is load generator. Once that's created, we'll wait for a few seconds before it starts loading and generating lots of load on our containers. So now if I go to run kube control top pods, for example, in order to see the CPU and memory utilization for my pods, I'll see the 2 load generators, and for my 2 pods here the load is still okay. I'll go to run that again and see the new consumption, and now you see the CPU utilization is around 255 and 377 for both of my pods. That's more than requested for my application. So remember, here we have set that those requests to 200 and the maximum to 500. And that CPU utilization is actually increasing. So here you see it is increasing step by step. So for now, the maximum utilization is still actually, the actual CPU utilization is still below the maximum, which was 500 for the CPU. So let's go to make this test even more interesting by increasing the number of the load generators. So here, instead of having 2, I'll go to run, let's say, 10 load generators, and let's see what the application will do for now. So I run again the command kube control apply, and then I apply the new load generator config that will run 10 instances or 10 containers that will be pinging our application in a loop. Now if I try to run top pods, from here I'll see the containers, the load generators that were created, and we see here the application pod is started to hit the limit. For this one it's already 501, and the load will be will still generating, or will still forcing those containers to consume more CPU and more memory to go beyond the limit, and then Kubernetes will stop those pods. So here this is the typical case where we want and where we need to scale our pods by adding the number of instances running those pods. So as we said, we can do this manually, or here we are interested in using the HPA, horizontal pod autoscaler. So let's see how that works. In this file here, hpa.yaml, I have a sample horizontal pod autoscaler definition. So that's the name, or that's the kind of the Kubernetes object that we are using. This one should actually point to a deployment. The deployment that it will point to is the PHP Apache. That's the name of our deployment that we have created earlier, like in here. And then we have some other arguments, like here the metrics. This is the important section where we can watch for the CPU or the memory utilization. Here I have taken this sample for watching only for the CPU, but we can also combine both. Note here I have in commands some other metrics that we can watch for. Those could be from external services, for example. So I'll watch for the CPU utilization for my pods. This is actually the average CPU utilization. It's not the CPU utilization for each pod. This is the average for all of my pods. So that should be 50%. 50% from the request. It's from this request, not from the limits. Kubernetes will always consider the request. So here, if the request for my container is 200, then the Kubernetes or HPA will make sure that what my pod is actually consuming is 50% of this 200. That means 100. So when that average is beyond, or it's above 50%, then it will increase the number of the pods by 1. And it will do that in a loop. If even increasing by 1, it's still, the average is still more than 50%, it will add a second additional one until it hits the max replica, which I set here to 10, for example. And now that's for scaling out. Now for scale in, we want to reduce the number of those instances, and that will be done once HPA will detect that the average utilization is below 50%, so it will decrease the number of pod instances by 1 until it hits the minimum replica of 3. So let's go to deploy this HPA and let's see how it works in Kubernetes. So I'll go to use the command kube control apply -f the HPA file. So you can remove here the dot and the slash, and this will deploy that HPA into my Kubernetes cluster. Great, and from here we can get some information about that HPA. So if I run kube control get HPA, this will give me the HPA that were deployed into my cluster, and you see here for now the number of replica that are running my application are only 2. But let's give it a few seconds and let's see it watching the targeted CPU utilization. For now it didn't get that target immediately because it will take some few seconds for the server metrics to get that utilization, and for HPA to get that utilization and take the decision either to increase or reduce the number of instances. So from here we see now the target is always 50%, but the actual consumption is 220. That's above the target. So then the number of replica was updated from 2 to 10. So HPA made the decision to make that number of replica to be 10. So now if I try to get the pods on my cluster, I see here my 10 load generators, and also I see that now I have 10 pods created and deployed in my cluster, and each of which they have CPU average utilization around 300 here. That's still more than the average that I have targeted, which was 50% of the 200 specified here. So how can I fix this? So here I have set the maximum of replica to 10. That's why here I can see only 10 pods deployed. But let's go to fix that. So I'll go to change that number now to 1000, and let's see how HPA will react to this change. So again, I go to deploy the new version of HPA. Once it's configured, we'll give it a few seconds, typically 15 or 20 seconds. And now if we try to get the new the HPA, we see here the number of replica is now 20. It's no more 10. So and if we run that again in a few seconds, we'll see that number will increase because the real utilization for now is still more than the targeted one. For that, you see here we have now 30 replica running our application. And as you can see, the number of replica have increased into 35 right here. So I can see those different deployed pods. So if I run kubecontrol get pods right here, I can see all the list of my 10 load generators and my application pods. And you can see some of them are pending to be created. So that's how the HPA can help us to scale our application by increasing or decreasing the number of the pods for our application. So again here, just a few remarks. So we have used the CPU and memory utilization, but note we can also use other metrics if we use the external or the custom metrics server. So the metrics server is an API defined inside Kubernetes, and that API could be implemented by other cloud providers in order to provide their own metrics that they can collect from the managed cluster like in AKS. So here I want to share with you some useful links. So this is the open source project for the metrics server that runs inside Kubernetes in order to get the metrics that would be available for the horizontal pod autoscaler. And then here we have the implementation of the metrics server as external or as a custom metrics server for Prometheus. So this one actually is an adapter that will connect into the Prometheus containers or Prometheus let's say server cluster in order to get some of the metrics collected by Prometheus and then scale the application based on those metrics. Those metrics could have something like the HTTP requests, the number of those requests, and so on. Sometimes it makes sense actually to scale not only based on CPU and memory utilization, but to be based on some other metrics like HTTP requests, for example. And then we have another adapters. Those are using the Kubernetes adapters. This is an implementation for AKS. It works also for other managed Kubernetes clusters. So this one actually will connect to Azure Monitor and Application Insights in order to get metrics from Azure. So those metrics could be, for example, the number of queue inside a service bus. So from here we can get that name of the queue that was created, that is available inside Azure Monitor and Application Insights. And then if the number of queues is 30, we'll go to increment the number of the replica. Otherwise, we'll go to reduce that number by 1. So this way we can extend the metrics that we can use in order to scale our application on. I leave you with a hint for the next video. So here if I run kubecontrol top nodes, for example, we can see that our 3 nodes are, let's say, somehow heavily utilized in terms of CPU and memory utilization. So what we want to do here is that we want to extend those scalability not only on the pod level, but we want to apply that scalability on the cluster nodes level. So we want to add or increase or decrease the number of the nodes running in our cluster. For that, we'll be using the AKS autoscaler. The next video, we'll see how that works.